Hey guys, how you all doing? I want all of you to put one good thing that happened to you today in the comment section. On that note, let's get started with the video. So last time we talked about working of the microscope. Let's just see it once again. A laser source is there which gets illuminated, produces monochromatic light source, those passes through confocal pinholes and ensuring that only specific wavelength hits our specimen, passing through dichromatic mirror, passing through objective lens and finally hitting our specimen. Out of focus, the light rays generated from the planes which are not under consideration and the light rays generated from the point of consideration called in focus planes are generated, they then pass through objective lens, pass through dichromatic mirror. Dichromatic mirror ensures that only fluorescent light, both out of focus and in focus planes, light rays reaches confocal pinholes and all the reflected light rays gets eliminated, and finally confocal pinholes further ensures that only in focus fluorescent light rays reaches our detector, and that's how bit by bit we are getting our image of the specimen. So now finally let's talk about the principle of the confocal microscope. First thing, it does not illuminate the whole sample at once. We know that we are not illuminating our whole sample at once. We are just taking a point of consideration. We are eliminating it, eliminating all the out of focus light rays, and then we are switching onto the another structure. So we are not illuminating the whole sample at once. Now using laser sources and confocal pinholes, we are spotting our particular spot at a particular depth of the specimen, and further we are eliminating it. So we know that laser source gets illuminated, there are confocal pinholes which ensure only specific wavelength gets reaches to our uh, specimen, and so we are illuminating a spot at a particular depth in the specimen. And finally, using another set of pinholes, we are further ensuring that the light rays coming from that particular spot, which is at there at particular depth, is reaching our detector. And finally, we are getting the final image of the specimen. I really hope the principle is now clear. If this confocal microscope is asked to you in the examination, you're not gonna write the principle after parts and working. I told you because I'm talking about the principle after parts and working because now I know that it is now clear, and I think I am right. Okay. So further, let's talk about advantages and disadvantages. Advantages, of course, resolution is much better. It is 40% better than your bright field and dark field microscopes. It's 200 nanometer, guys. Moreover, we are getting 3D images and we can study all the living microbial communities. You must have talked about lichen in your high school. So all those biofilms, all those association can be studied without disturbing them. The advantages are clear and the disadvantages, it's expensive. No wonder why we are you routinely using bright field, because bright field microscope, because it is cheap and it is easy to handle. Confocal microscope, electron microscope, fluorescent microscopes, these all are expensive, and so they are found in only in like rich laboratories. Pinhole related issues can be generated because wavelength related issues can be generated, but is sometimes these issues are not there, but it might be possible that issues that generated. Now this is the confocal microscope. I want you to look at it, observe it. We are having UV light source and we are ensuring that only UV light ray source hits our specimen and not ourselves. All the detectors and everything we are having here. Now before looking at the image, look at her. Isn't she looking cool? I mean, like all the people who are doing research, I think they look cool. Now, whatever, here we are getting a 3D image on the screen and all fluorescently colored and beautifully detailed, right? The other images can be your 3D images, the other images can be these images which are detailing you, which are giving you the specific details about everything. If you're gonna see these things under bright field microscope, forget about the, you know, forget about the minor details. You'll not be able to see it only until unless you stain it properly and all. The last thing, maybe fibroblast, we talk about. Fibroblasts are like these. You can see the nucleus and everything, which are pretty clear under the confocal microscope. Now here I want you to look at the pollen grain developmental stage, the life stages that it undergoes. Using confocal microscope, we can see that it is developing, then it is maturing, and then it is germinating, breaking its cell wall onto the favorable condition, and then it's finally removing all the hard kind of walls and finally germinating to give rise to the plant. So with that, guys, talking about parts, working, principle, advantages, disadvantages, we talked about everything confocal microscope that was there. And last time I told you, put your doubts in the comment section. With that, thank you so much, guys, for hearing me out, and bye bye. Let's meet another time. Take care.